Okay, so to continue with this example, we now need to figure out the kite problem. And the kite problem isn't quite as straightforward. And the property that we need to remember is that the diagonals bisect each other and bisect the one, but they're perpendicular to each other. So I already know from my previous work that these two are equal. And so somewhere down here, there's going to be an intersection. So if I use the idea that the diagonals are perpendicular, I can figure out where this line is going to come through from B to D. So we could do the slope formula on A to C, or we could do it the old-fashioned way and count up 1, right 2, up 1, right 2, and if Mrs. Green draws a straighter line, we know that the slope from A to C is 1/2. Now if they're perpendicular, that means that the slope from B to D is opposite reciprocal, -2/1. And that old-fashioned way works pretty slick. If I start at B and I go down to 1, 2, right 1, that's a triangle, so I got to keep going, down 1, 2, right 1. That puts us at a rhombus point, which remember we had that whole debate if a rhombus is a kite is a rhombus, so we're going to skip that one. We're going to go down 1, 2, right 1, and now we are at 6, -2. There is one choice. I could go down 1, 2 more, and right 1 to 7, -4, and I could hit another point, and I could keep going down and find numerous kites on that perpendicular bisector. Remember, this bisects and it's perpendicular. If you go back even further, this picture looks a whole lot like that perpendicular bisector picture I drew with the guide wires because it's the same theorem. So a couple of examples here. So D could be 6, -2, or it could be 7, -4, for example. Now, final example. We have to look at what do we do to name these things without any numbers. Well, we're going to start with 0, 0, because that's our favorite place. And we know that the coordinate over here of y is going to be 0 because we haven't gone up any. Now, those right triangles are going to be very important again. If you think about how you move on a graph, we would go over, let's say, A units, and then to get to this point right here, we would go up, let's say, B units. So we would be at A, B. Now, to get to this one, I'm going to go over a new amount. I don't know what that is. I'm going to call it C. It's not related to A or B. But I see that I have this right triangle showing up right here. I know the distance from here to here is A because it's the same as right here. So to get from C out to this point to go up for this coordinate, I went over C units, and then I went over A more, and so that is C plus A. And because this is a horizontal line, I am B high in my coordinate system. And that is all there is to using letters only. Those right triangles and parallelograms and isosceles trapezoids, very pivotal in knowing how to relate coordinates with variables and using the fewest number of